This question says, a chemist dissolves 282 milligrams of pure perchloric acid in enough water to make up 280 milliliters of solution. And then it says calculate the pH of the solution. So perchloric acid is one of the strong acids. In a previous video I discussed how these are not the only strong acids, because strong is a qualitative term, and if you watch that video you can get a little more on that. But here we have perchloric acid as a strong acid. When we dissolve a strong acid like perchloric acid, HClO4, in water, it completely reacts with the water to form H3O plus, aqueous, and ClO4 minus, aqueous. So it'll completely react with the water to form H3O plus. If you recall, pH equals negative log of the concentration of H3O plus. So if this completely reacts to form H3O plus, if we know the concentration of HClO4, we therefore know the concentration of H3O plus, and we can then find the pH. So how do we do that? Well, what we need to do is we need to convert from grams of HClO4 to moles of HClO4, and then divide those moles by liters of solution, and then that'll give us the molarity, because remember, molarity is moles per liter, so this isn't truly dimensional analysis, we're dividing by the liters. So we can't use milligrams, we have to use grams. So if we start with 0.282 grams, divide that by 1,000, of HClO4 times, we put the molar mass on the bottom to convert to moles, which is 100.46 grams of HClO4, and on top 1 mole of HClO4, times, to divide in this dimensional analysis like scheme, we put just a 1 as a placeholder on the top, and then we put the volume in liters on the bottom, which is, take that divided by 1,000, or 0.280 liters. When you do that math, you find that this is 0.010025 molar perchloric acid solution. Note that there are 3 sig figs, so that's the digit that I care about. So we have the concentration of HClO4, and since HClO4 reacts completely with water, what we really have is the concentration of H3O plus. So we can plug that in. pH equals the negative log of the concentration of H3O plus, which is 0.010025 molar. The pH equals, the first digit doesn't count as a sig fig, and then we need 3 digits after that, and we're going to plug this into our calculator, which is 1.999. These 3 nines are your 3 sig figs, which matched your 3 sig figs here, your 1, 0, and 0. Note that you can only find the pH this way by finding the concentration of the acid if it is a strong acid. If you have a weak acid, which you will later, you can't do this. So this only works if you have a strong acid where all of the acid forms H3O plus, which is the definition of a strong acid.